Dear students, plus 1 Computer Science Chapter 4 Principles of Programming and Problem Solving Part 3. In the last class, we discussed about the different phases of programming, and the different phases are problem identification and preparing algorithm and flowchart, then translation, coding, execution testing, and then last step is documentation. Today we are going to discuss about different questions or examples to create algorithm and flowchart. So the first question is write the algorithm and draw the flowchart to find the area and perimeter of the rectangle. So first we want to know the what is the equation, how the problem identification, how to identify this problem by we can apply the equations to find the area and perimeter of the rectangle. How to find the area of the rectangle? It is length into breadth, and the perimeter is 2 into sum of length and breadth. So the algorithm is step 1 start input, step 2 is input length and breadth. Here for the rectangle there is only two variables or two inputs, length and breadth. Then after getting length and breadth we find the perimeter equal to 2 into L plus B, then area equal to L into B, that is the product of length and breadth. And then after getting perimeter and area, display the output as print P comma A, P for perimeter and A for area. And the after displaying output or printing the output, then last step is stop. And the flowchart for this algorithm is like this. First I'll start, use the terminal symbol for input, use the parallelogram for process, that is perimeter and area process step by rectangle shape, and the print output statement used parallelogram, and the last step stop used by the terminal symbol. It is the algorithm and flowchart to find the area and perimeter of a rectangle. And the next is algorithm and flowchart to find the height of the taller one among two students. How to find the taller one from two students? Just compare, input the height and just compare the values by using less than symbol or greater than symbol. So here the algorithm is step 1 start, step 2 input h1 and h2 as two heights. For the first student use the h1 as the height, for the second h2. Then compare. If h1 greater than h2, if h1 greater than h2, what is the result? Then highest student is tallest student is h1. Else if it is wrong, h1 greater than h2 is wrong, then the tallest student is second student. So here step 3, if h1 greater than h2, then print h1. Else in the step 5, else step 6 h2, print h2. H2 is the tallest student. Then end of if. This if statement is take place during the step 3, 4, 5, 6 and 7. After getting the result, print h1 and h2. Print h1 or print h2. After getting the result, step 8 stop. And here we use a decision. If h1 greater than h2, there will be two flow lines, that is for we use the decision box or the rhombus. And the flowchart is first use the start symbol by start by using the terminal, then input parallelogram, then after input that comparison for compare or taking a decision, we use the rhombus symbol as a decision symbol. Rhombus, it has one input and one data in and two data flow out. Here is h1 greater than h2, is it true? If it is true, then go to the yes, that is print h1. Else if it is wrong, go to the print h2. Then combine these two, and last step is stop. If decision or rhombus has two flows, and for yes and no. If yes means is h1 greater than h2. If it is true, then the tallest student is h1, otherwise tallest height is h1, otherwise it is, if it is no, that is the tallest height is the second student's height, that is h2. After printing these h1 or h2, then the last step stop. And the next algorithm is algorithm to input the scores obtained in 3 unit tests and find the highest score. Here 3 inputs, so we use the 3 comparisons, and the algorithm is start and input M1, M2, M3 as the marks for 3 unit tests. If M1 greater than M2, if M1 greater than M2 and M1 greater than M3, then print M1. That is, if M1 greater than M2, if it is true, M1 is greater. And that M1 greater than M3, if these two and means logical and means if both the inputs are true, the result is true. If any of the input is false, the output is false. Here, if M1 and M2 and M1 and M3, here compare M1 and M2 and M1 and M3. M1 greater than M2, which means if it is true, M1 is greater. M1 greater than M3, if it is true, M1 is greater. So, the print statement. Otherwise, else M2 greater than M3, check M2 greater than M3. If it is true, print M2, it is great. Else statement for this statement, if it is false, then it is print M3. M3 is the lowest, highest score. And end of if. Step 3, 4, 5, 6, 7, 8, 9, including the if statement, and the last statement is stop. And the flowchart for this is start, input 3 marks as M1, M2, M3. Then compare these two statements with the decision box, that is, or the rhombus box. Is M1 greater than M2 and M1 greater than M3? Go to the yes. If it is true, print M1. Else, go to the next decision box. Is M2 greater than M3? Here again two boxes, two outputs. If it is true, print M2, otherwise it is print M3. Then 3 print statements are flow to the stop statement. It is the flowchart for input scores obtained in 3 units and find the highest score. And the next algorithm is algorithm and flowchart to print the numbers from 1 to 10. In this algorithm, a condition is checked at step 5. If the condition found true, the flow of control is transferred back to step 3. So, step 3, 4 and 5 are executed repeatedly as long as the condition is true. We will say that the loop is formed here. Here, look here, step 3, 4 and 5. Here step 1 is start, then n equal to 1. So, the because of the print from 1 to 100. So, first number is 1. Then print n. So, print 1. So, 1 is printed here. And next n equal to n plus 1. So, initial value of n is now 1. Then after the fourth step n equal to n plus 1. So, the value of n becomes 1 plus 1, 2. Then check. Now the value of n is 2. 2 less than or equal to 0. If it is true, go to step 3. So here in the algorithm, a condition is checked at step 5. If the condition is found true, the flow of control is transferred back to step 3. So step 3, 4 and 5 are executed repeatedly as long as the condition is true. That we will say that a loop is formed here. And step 3, 4, 5 constitute a loop. The control comes out of the loop only when the condition becomes false. That is, if we print 1, 2, 3, 4, 5 etc. up to 100. Then when the value of n is 100, then go to step 3. Then print 300. Then the value of n becomes increased by 1. Then n equal to 101. If 101 less than or equal to 0, it is false. Then exit from the loop, that is 3, 4, 5. Then stop the printing. And the flowchart of this algorithm is start N1, then print the statement. Then go to n equal to n plus 1. Then check whether the condition is true or false. If it is true, go to the step 3. That is step 3 is print n. Just go to the print step 3. Before that we join to the data flow line. If it is false, when a value of n equal to greater than 100, then go to the last step, stop. And this program is also written as in another way, that is start n equal to 1. Repeat steps 4 and 5 while n less than or equal to 0. N less than or equal to 100. Step 4, print n. Step 5, n equal to n plus 1. And the last step is stop. Note that in step 3, the word repeat and while are used to construct a loop. The statements that need repeated execution is specified in the word repeat, and the condition is given with while word, while. As the algorithm looks slightly different, the flowchart is also differs slightly as this. Here step 1 start, step 2 n equal to 1, and step 3 repeat steps 4 and 5 while a condition is n less than or equal to here. So first we check 1 less than or equal to 100. Is it true? Yes. Then go to the fourth step, print n. So first print the value 1. Then the value of n is increased by 1. Then n equal to 2. Then go to again repeat steps 4 and 5. Then go to check the condition in step 3. 2 less than or equal to 100. Yes, it is true. Then print 2. Then the value of n is again 3, 4, 5, 6, etc. up to 100. Then when the value of n equal to 100, then print the n. Print 100. Then n equal to 100 plus 1, 101. Then go to the step 3. Then the 101 less than or equal to 100 is false. Then don't repeat steps 4 and 5. When repeat the steps 4 and 5, only when the condition n less than or equal to 100. When the value of n is 101, it is wrong, and go to the step 6, that is stop. And the flowchart is start, n equal to 1, condition checked, condition, if it is the condition is true, print n, then go to n equal to n plus 1, that is the value of n is increased 1 while. Again go to the decision box or the rhombus, repeat these steps if the condition is only true. If the condition is false, then go to the stop step. And next algorithm is algorithm and flowchart to print the sum of first n natural numbers. What are the sum of first? What are the natural numbers? 1, 2, 3, etc. Here we want to print the sum of first n natural numbers. So the algorithm is first step start, then input n. Step 3 a equal to 1. Step then s equal to 0. For this sum we use the variable as s, and the a equal to 1 means the first natural number. Repeat step 5 and 6 while a less than or equal to n. Here n is the limit. Suppose first print the 10 sum of first 10 numbers. So that time n equal to 10. First 100 numbers, then n equal to 100, and n is the limit. Then s equal to s plus a equal to a plus 1, print s, stop. Suppose an example, if the value of n equal to 5, then we consider the example. In the example we consider the value of n equal to 5. So start, input n has the value 5, a equal to 1, s equal to 0. Repeat steps 5 and 6 while 1 less than or equal to a less than or equal to n. Here a equal to now 1 and n equal to 5. Consider as n as 5. And s equal to s plus a, that is s equal to 0 plus 1. So the value of s equal to now 1. Then a equal to a plus 1. The value of a becomes increased by 1 and the value of a is 2. Then print s. So now the value of s is, print s means, repeat step 5 and 6, a equal to 2. Then go to step 4, 2 less than or equal to 5, yes it is true. Then go to step 5, s equal to s plus a, that is 1 plus 2. Then go to a equal to a plus 1, that is a, the value of a is 3. Then continue this step. When the value of a is 5, then 5 equal to, then a equal to 5 plus 1, 6. That is 6 less than or equal to 5. It is wrong, and go to the step 8. And the flow chart is like this. Start input a equal to 1, s equal to 0. Is a less than or equal to n? If it is true, go to s equal to s plus a, then a equal to a plus 1. Repeat these steps when the condition is true. If the condition is false, print the s and stop the statement. And next question is algorithm to print first 10 multiples of a given number. And the output, and the algorithm: step 1 start, step 2 input n, that is the input n integer number a equal to 1, m equal to a into n, that is the multiplication. Print m a equal to a plus 1. Repeat steps 4 to 6 while a less than or equal to 10, and the last step stop. That is here. Then the flow chart is: start input n a equal to 1, m equal to a into n, print m a equal to a plus 1. Is a less than or equal to 10, go to the fourth step. Then when the condition is false, go to the stop step. Consider n if n is 2. Start input 2, a equal to 1, m equal to 1 into 2. What is 1 into 2? 2. Print 2, a equal to a plus 1 up to 10. The first 10 multiples of a number. When the value of a is greater than 10 or the value of a is 11, stop the repeated step and go to the last step, stop. And next is here we used the while and do while or go to statements. These statements are known as entry controlled loop and exit controlled loop. This algorithm compare two values. The last section we discussed about several comparison algorithms. That comparison algorithms are looping algorithms. That is, there are two types of loops: entry controlled loop and exit controlled loop. If the condition is checked before the execution of the body, it is known as entry controlled loop. Before entering into the loop, if we checked the condition, it is known as entry controlled loop. If the condition is checked after the execution of the body or the exit portion of the body, it is known as exit controlled loop. In entry controlled loop, body may never be executed because of if the first we check the condition, if the condition is wrong, not entered into the loop, so body may never be executed. But in the exit controlled loop, body will be executed at least one, because after executed in the loop, at last we check the condition. So in the exit controlled loop, body will surely be executed at least once. And entry controlled loop, the third statement: suitable when skipping of the body from the being executed is required. We can skip from the body from the being executed required in the entry control loop, but in the exit control loop suitable when the normal execution of the body is to be ensured. In the normal execution of the body is used in the execution is used in the entry control loop, but in the case of entry control loop, when the skipping of the body from being executed is required. Hope all these topics are clear to you. Thank you, students.